Good morning. The previous video lecture we have discussed about 8086 microprocessor architecture and working. In this video we will discuss about the 8086 pin and its signals and also the minimum and maximum mode of operations of 8086. Let us start with address bar data bus. The address bar data bus AD0 to AD15 or bidirectional buses. The lower order address bus, these are multiplexed with the data bus. When AD lines are used to transmit memory address, the symbol A is used instead of AD. For example, A0 to A15. When data are transmitted over AD line, the symbol D is used in place of AD. For example, D0 to D15. A16 combined with S3, S4, S5, S6 are nothing but of higher order address buses. These are multiplexed with the status signals. The S6, S5, S4 and S3 are the status signals. Next, let us discuss about the bus high enable pin number 34. It is used to enable data onto the most significant half of the data bus, D8 to D15. 8-bit device connected to upper half of the data bus uses BHE, that is active low signal. It is multiplexed with the status signal S7. This pin signal indicates what mode the microprocessor is to operate in, whether it is being operated in minimum mode or in maximum mode. And this pin number 32 RD bar, this signal is used for read operation. It is an output signal and it is active low when it is being activated. Next, pin number 23 test. Test input is tested by the wait instruction. 8086 will enter a wait state after execution of the wait instruction and will resume execution only when the test is made low by an active hardware. This is used to synchronize an external activity to the microprocessor's internal operation. The ready pin number 22. This is an acknowledgement for the slow device or memory that they have completed the data transfer. The signal made available by the devices is synchronized by the 82848 clock generator to provide ready input to the 8086. This signal is an active high. Next pin is pin number 21 reset. This causes the microprocessor to immediately terminate its present activity. The signal must be active high for at least 4 clock cycles. Pin number 19 clock. The clock input provides the basic timing for processor operation and bus control activity. It is an asymmetric square wave with 33% duty cycle. Next, pin number 18 INTR, interrupt request. This is a triggered input. This sampled during the last clock cycle of each instruction to determine the availability of the request. If any interrupt request is pending, the processor enters the interrupt acknowledge cycle. This cycle is active high and internally synchronized. Then pin number 40 VCC, it provides complete supply, positive 5 volt supply for the operation of 8086 microprocessor. Next, let us discuss about the minimum and maximum mode operation related pins. The 8086 microprocessor can work in two modes of operation, minimum mode and maximum mode. In the minimum mode of operation, the microprocessor do not associated with any co-processors and cannot be used for multiprocessor system. In the maximum mode, the 8086 can work in multiprocessor or co-processor configuration. Minimum or maximum mode operations are decided by the pin min slash max. When this pin is high, 8086 operates in minimum mode. Otherwise, it operates in maximum mode. For minimum mode operation, the min-max pin, that is pin number 33, is tied to VCC, that is logical high, indicating minimum mode of operation. 8086 itself generate all the bus control signals. DT slash R bar, pin number 27, that is data transmit bar receive. Output signal from the processor to control the direction of data flow through the data transceiver. Data enable, pin number 26. It is an output signal from the processor used as output enable for the transceiver. Pin number 25 ALE. Address latch enable, used to demultiplex the address and data lines using external latches. Pin number 28 memory slash IO bar, used to differentiate memory access and IO access. For memory reference instruction it is high, for in and out instruction it is low. Pin number 29 write bar, write control signal. It is asserted low whenever processor writes data to memory or IO port. Pin number 24 interrupt acknowledge. When the interrupt request is accepted by the processor, the output is low on this line. Pin number 31 hold, input signal to the processor for the bus master as a request to grant the control of the bus, usually used by the direct memory access controller to get the control of the bus. Pin number 30 hold acknowledge, acknowledge signal by the processor to the bus master requesting the control of the bus through hold. The acknowledge is asserted high when the processor accepts hold. Maximum mode signals. During maximum mode operation, the MN by MX pin, that is pin number 33, is grounded, that is logical low. Pin number 24 to 31 are reassigned. Pin number 26 to 28 S0, S1, S2 are status signals used by the 8086 bus controller to generate bus timing and control signals. These are decoded as follows. When these three pins are of 0, then it is of interrupt acknowledge machine cycle. If it is of 001, then it is of read input output port. If it is of 010, it is of write IO port. If it is of 011, then it is of halt. If it is of 100, it is of code access, and if it is of 101, it is of read memory. If it is of 110, then it indicates write memory, and if it is of all ones, then it is a passive or inactive. That is, the processor is passive or it is inactive. Pin number 25 and 24 QS0 and QS1. These are all queue status. The processor provides the status of the queue in these lines. The queue status can be used by external devices to track the internal status of the queue in 8086. The output on QS0 and QS1 can be interrupted as shown in the table. If both the pins are of 0, no operation takes place. If it is of 0, 1, then first byte of an opcode from queue is taken out. If it is of 1, 0, then the queue is completely empty. If it is of 1, the subsequent byte from queue is being taken. Let us discuss about pin number 31 and 30 related to maximum mode operation. RQ slash GT, that is bus request slash bus grant. These requests are used by the other local bus masters to force the processor to release the local buses at the end of the processor's current bus cycle. These pins are bidirectional. The request on GT will have higher priority than GT1. Pin number 29 lock, an output signal activated by the lock prefix instruction. It remains active until the completion of the instruction prefixed by lock. The 8086 output low on the lock pin while executing an instruction prefixed by lock to prevent other bus masters from gaining control of the system. Okay, let us start discussing about the modes of operation of 8086. We begin with minimum mode of operation. In this mode, the microprocessor 8086 is operated by strapping its min-max pin to logic 1. So in this mode, all the control signals are given out by the microprocessor chip itself. There is a single microprocessor in the minimum mode. The remaining components in the system are latches, transceivers, clock generators, memory and I/O devices. Latches are generally buffered output D-type flip-flops like 74LS373 or 8282. They are used for separating the valid address from the multiplexed address or data signals and are controlled by the address latch enabled signal generated by 8086. Transceivers are the bidirectional buffers used to separate the valid data from the time multiplexed address or data signals. They are controlled by DEN and DTR. The DEN signal indicates the direction of data, that is from or to the microprocessor. The system contains memory for the monitor and user program storage. Now let us discuss about the read cycle timing diagram for minimum mode. The read cycle begins in T1 with the assertion of address latch enabled signal and also memory or I/O signal. During the negative going edge of this signal, the valid address is latched on the local bus. The BHE and A0 signal address low, high or both bytes. From T1 to T4, the memory bar I/O signal indicates a memory or I/O operation. At T2, the address is removed from the local bus and is sent to the output. The bus is then tri-stated. The read control signal is also activated in T2. The read signal causes the address device to enable go slow. The valid data is available on the data bus. The addressed device will drive the read line high. When the processor returns the read signal to high level, the addressed device will again tri-stated its bus drives. The read cycle begins in T1 with the assertion of address latch enabled signal and also memory / I/O signal. So this continues for read cycle timing diagram for minimum mode. Now let us discuss about the write cycle timing diagram for minimum mode. A write cycle also begins with the assertion of ALE and the emission of the addresses. The memory or I/O signal is again asserted to indicate a memory or I/O operation. In T2, after sending the address in T1, the processor sends the data to be written to the addressed location. The data remaining on the bus until middle of T4 state, the write becomes activate at the beginning of T2. Unlike read is somewhat delayed in T2 to provide time for floating in the read cycle. The BHE and A0 signals are used to select the proper byte or bytes of memory or I/O words to be read or write. The memory or I/O read and write signals indicate the type of data transfer as specified in the table which we have discussed previously. Now let us discuss about the maximum mode of 8086. In maximum mode, the 8086 is operated by strapping the min-max pin to ground. In this mode, the processor drives the status signal S2, S1 and S0. Another chip called bus control drives the control signal using the status information. In the maximum mode, there may be more than one microprocessor in the system configuration. The components in the system are same as in the minimum mode system. The basic function of the bus controller chip IC8288 is to derive the control signals like read and write from memory and I/O devices. DEN, DTR, ALE, etc. using the information by the processor on the status lines. The bus controller chip has input lines S2, S1, S0 and clock. These inputs to 8288 are driven by the CPU. It drives the output ALE, DEN, DTR, MRDC, MWTC, AMWC, IORC, IOWC and AIOWC. The AEN, IOB and CEN pins are specially useful for multiprocessor systems. The AEN and IOB are generally grounded. CEN pin is usually tied to positive 5 volts. The significance of MCE or PDEN output depends upon the status of the IOB pin. The INTA pin used to issue 2 interrupt acknowledges pulses to the interrupt controller or to an interrupt device. The IORC, IOWC or IO read command and IO write command signals respectively. These signal enables an IO interface to read or write the data from or to the address port. The MRDC, MWTC are memory read commands and memory write command signals respectively and may be used as memory read or write signals. All these command signals instruct the memory to accept or send data from or to the bus. Here, the only difference in the timing diagram between minimum and maximum mode is the status signal used and the available control and advanced command signals. So let us discuss about the read and write timing diagrams in maximum mode. The R0, S1, S2 are set at the beginning of bus cycle. 8288 bus controller will output a pulse as on the ALE and applies a required signal to its DT/R pin during T1. In T2 state, 8288 will set DEN is equal to 1, thus enabling transceivers, and for an input it will activate MRDC or IORC. These signals are activated until T4 state. For an output, the AMWC or AIOWC is activated from T2 to T4 and MWTC or IOWC is activated from T3 to T4 state. The status bit S0 to S2 remains active until T3 and becomes passive during T3 and T4. If read input is not activated before T3, wait state will be inserted between T3 and T4. So that's all with the pin signals and minimum maximum mode of operation of 8086. See you all in the next video. Thank you.